everyone, this is Rhogen Esteban and I'm reporting today for our Computer for Engineering, which we're gonna talk about the modeling computers and error analysis together with my partner Vincent Jomar. So first, we can use manually solving more problems about math, but it make easier when we are using technology. So now we are using a MATLAB. So our first objectives is to analyze data, create models, applications, be able to define MATLAB and its uses, develop algorithms, and learn basic operations on how to use MATLAB. So first, modeling computers and error analysis. A mathematical model can be broadly defined as a formulations or equations that expresses the essential of physical systems or process in mathematical terms. In every general sense, it can be presented as functional relationship of the form. Next, we have the characteristic of mathematical model. First, it describes a natural process or system in the mathematical terms. Secondly, it represents an idealizations and applications of reality. It is the model ignores negligible details of natural process and focuses on the essential of manifestations. Thus, the second law does not include the effect of relativity that are minimal importance when applied to objects and forces that interact on about the Earth's surface or velocity on the scales visible to human eye. Next, we have it yields reproductively results and consequently can be used for predictive purpose. For example, it can be the force of an object and its mass are known. That's the characteristic of mathematical model. Next, we have the conservation's law and engineering in sciences. Conservation law states that the particular measurable property of an isolated physical change does not have changed as the system evolved over time. So means change is equals to increase minus decrease. Now, let's define MATLAB fundamentals. MATLAB fundamentals is a high-performance language for technical computing. It integrates computation, visualizations, and programming in an easy-to-use environment where problems or solutions are expressed in familiar mathematical notation. Typical uses includes math and computations, algorithms development, modeling, simulation and prototyping, data analysis, explorations and visualization, scientific and engineering graphics, and applied to graphical users interface buildings. That's math fundamentals defined is. So they use math fundamentals in solving more easier in terms of those math computations, algorithms, and any problems that can be based on mathematical notations. MATLAB is an interactive system whose basic data elements is an array that does not require dimensioning. This allows you to solve many technical computing problems, especially those who are matrix and vectors formulations. It is a fractions of time it could take to write program. It's scalar non-interactive language such as C or Fortran, or that's the C++ on JavaScript for IT students. The name MATLAB stands for the Matrix Laboratory. Was originally written to provide easy access to matrix softwares developed by Linpack and Ispax, which together represent the states of the art in software or matrix computations. MATLAB has evolved over a period of years, which input from many users in universities environment. It is a standard interactional tools for introductory and advanced courses in mathematics, engineering, and sciences. In industry, MATLAB is tools to choose high productive research, development, and analysis. MATLAB features a family of application specific and solutions called the toolbox. This MATLAB is more different from the C++ or any software or that programming HTML or any visual basics in a computer way. But toolboxes are the comprehensive collections of MATLAB functions. These tools composed of those scripts, syntax, those are the languages that they are using on MATLAB or your matrix laboratory. And now let's define MATLAB system main parts. So we have the two parts for the MATLAB system. First is the language or the MATLAB language. This is the higher level of matrix array language with a control flow statements, functions, data, structures, input or output, and object-oriented programming features. It allows both programming in the small or to rapidly create quick and dirty throwaway programs, and programming in the large to create complete large and complex applications program. Secondly, the parts of the MATLAB system, the MATLAB working environment. This is the set of tools and facilities that you can work with a MATLAB users or programmers. It includes facilities for managing the variables in your workplace and importing and exporting data, and also included tools development, management, debugging, and profiling M files or MATLAB's applications. Though those are the MATLAB system main parts. First is the MATLAB language, and secondly is the MATLAB environment. We have also the handle graphics. This MATLAB graphics system, it includes the high-level commands for 2-dimensionals and 3-dimensionals data visualizations and image processing, animations, and presenting graphics. We have also the MATLAB mathematical functions library. It is the vast collections of computational algorithm ranging from elementary functions like sum, sine, cosines, and complex arithmetic to more sophisticated functions like matrix inverse, matrix Rhogen values or visual functions, and fast Fourier functions. And we have the MATLAB application program or the API. This library that allows you to write C and Fortran programs that interact with MATLAB. It includes facilities or calling routines from MATLAB's as a functional engines and to read your writing mathematical program. And now let's define M files in MATLAB. An M files or script files is the simple text where you can place MATLAB command. When the file is run, MATLAB reads the command and execute them exactly as it would if you have to type each command and sequentially at the MATLAB prompt. All M files names must be end at the extension of .m. So please memorize that every files coming from MATLAB, the extensions of the file must be .m. If you create a new file with the same name as existing M file, MATLAB will choose the one which appears first part or order. It is to make life easier to choose a name or for your M file which doesn't already exist. To see if the file name is already exists, type help file name at the MATLAB prompt. So the help file name at the MATLAB prompt will identify if there are the same file name that you are creating for. Next, let's define input and output in MATLAB. The varigrain arguments and cell array that contains the functions inputs where each input is in the whole cell. Super variable numbers or output defined as the function that return a variable numbers of output arguments using varag outs. Next, we have the MATLAB runs from functions using the first run command in the list. For example, click run to run on my functions using the command result is equals to my functions. MATLAB display the result in the command window. To run the function using different run command from the list, click run and select desired command. So there are many functions or there are commands that we need to consider in running our MATLAB programs, especially on keeping your command results. So the display of the results will be prompt on the command window. Next, we have the structured programming in MATLAB. structures, we have the structured programming in MATLAB. Structured programming or the modular programming is a software development paradigm in which problems are solved in top-down fashions. A natural starting point is discussions in structural programming. MATLABs will be quick review of the element structures programming, also known as the conditional structures. Selection structures is a programming features that performs different process based on whether a volume discussed nesting and indentation in MATLAB. MATLAB indent code such as functions of the body of the loops in the editor and live editors. When you ident lines by using or space, MATLAB also aligns subsequently lines with those lines you can enable or disable automatic and depending on how you prefer to write your codes. Next, we have the passing functions in MATLAB. First is the deep repeat functions, and you can have it shortcut just tab function n. We have the return functions. We have the deep square. Return in 2 or output is equals to repeat square to 3. Use repeat to call required with 3 as arguments. Then you can have it the printout. Now let's proceed with the round-off and truncations errors. First, round-off and truncations errors. Round-off errors is errors used by the approximate representations of number. When the people talk about round-off errors, it's the errors between the numbers and its presentations. It's short round-off error that caused by representing numbers approximately. Truncations error is caused by approximately mathematics procedure. So they are the decimals on your answers. Next, we have the errors in MATLAB. Syntax and routine errors are always two types of errors that appears in MATLAB. To make sure warning or errors messages are specific, insert component or the message as the time executions. The warning functions uses conversions character that are same as those by the sprint functions. Conversation characters such as placeholders to substring or values are unknown until the code executes. So we can use errors functions on the specific ends by inserting the component of messages so that you can correct it properly. Now let's talk about round-off errors in MATLAB. The following approaches can help you recognize and avoid incorrect results. First is the using symbolic computations when possible. Next is the perform calculations with increased precisions. Third is to compare symbolic and numeric results. And lastly, plot the functions or expressions. That's the way on how you help you recognize the incorrect results on your programming skills. Next, we have the truncations error in MATLAB. Truncations errors are different between truncated values and actual values. As an example of truncations error, consider that the speed of light in a vacuum, the official value is at 299,792 and 47 meters per second in specific power of 10 notations. The quantity is expressed as 2.9979294858 raised to 10 times 10 raised to 8. Truncations errors defined as the difference between the value analytically derivatives of a function and its derivative obtained by numerical approximations. We have the total numerical errors in MATLAB. The simplest approach is to use an if or which statement to check for a specific conditions and use it error or warning. Try it, see. Now let's talk roots and optimizations. First, what are the roots bracketing methods? Roots in MATLAB, the roots functions calculates the roots of single variables. Polynomials represented with the vectors of coefficients. How do you write roots in MATLAB? So first, square root of MATLAB functions b is equal to the square root of x. Return the square root of each element at the array of x. For the elements of x that are negative or complex, the square root of x produce a complex result. Graphical method and MATLABs. Graphical methods or geometric methods allows solving simple linear programming problems, and visually this method is limited to 2 or 3 problems decisions variable, since it is not possible to graphically illustrate more than a 3D. Next, we have the graphical methods in MATLABs. And now let's talk linear system. Linear algebraic equations and matrices. X is equals to ln solve AB, or the X are in solve as AB. X in len solves AB solves the matrix equations as AX is equals to B, where B is the column vectors. Example, bracket of X in R is equals to ln solve open and close parenthesis AB, also return the reciprocal of the conditions number of A of V, the squared matrix, otherwise ln solve returns to the rank of A. Next, we have the A is the coefficients. Symbolic matrix or coefficient matrix specified as the symbolic matrix. B as the right sides of the equations. Symbolic vectors or symbolic matrix, right sides of the equation specified as the symbolic vectors or the matrix. Next, we have the Gauss eliminations or the Gauss eliminations. Gauss eliminations is the linear or multilinear algebraic process for finding the solutions of a system or simultaneously linear equations by the first solving one of the equations for the variables. Next, Gauss added the rows pairwise. Each pair add up to n plus 1, and there are the n pairs to the sum of the rows is also n divided by time, or n plus 1. It allows the 2 times or the 1 plus 2 plus 1 dots plus n is equals to the times from which we obtain the formula. Gauss formula is a result of counting quantity as cleverly way. And now let's talk about LU factorizations. LU decompositions of matrix is the factorizations of given square matrix into 2 triangular matrices, one upper triangular matrix and one lower triangle matrix, such as that the product of these 2 matrices give the original matrix. It was introduced by the Alan Turing in 1948. It's also created the Turing machines. So that's the LU factorizations. Next, we have the Klossky method. Klossky decompositions or factorization is a powerful numerical optimization techniques that is widely used in linear algebra. It decomposes an Hermitian positive defined matrix into a lower rectangular and its conjugate components. This can be later be used for optimal performance in algebraic expressions. Next, we have the matrix inverse and conditions. The matrix must be square, sum of the numbers in row and columns. The determinants of the matrix must not be a 0, or determinants are covered in sections of 6.4. This is the instead of the real number not being 0 to have inverse. The determinants must be not 0 to have an inverse. Next, we have the iterative methods. The iterative methods are mathematical ways of solving problems which generates a sequence of approximations. These methods is applicable for both linear and nonlinear problems with a large number of variables. So a method for approximately solving a system of linear algebraic expressions AX is equals to B that can be transformed to form X is equals to Bx plus C. The solutions is looked for as the limit of sequence xk plus 1 is equals to B xk plus C. K is equals to 0, 1, or any integers numbers where x0 is initials approximately of these iterative methods. Now let's proceed with our part 5, which is the curve fitting. Now let's define curve fitting in MATLAB. Curve fitting is one of the most powerful and most widely used analysis tools in Origin. Curve fitting examines the relationship between one or more predictors and irresponsible variables with the goals of defining a best fit model of a relationship. First is the method of least square is widely used method of fitting curves for given data. It's most popular method used to determine the positions. Next, we have the linear regressions. Linear regressions attempts to model the relationship between two variables by fitting a linear equation to observed data. A linear regressions line has an equation the form y is equals to a plus bx, where x is the explanatory variable and y is the dependent variable. Next, linear regression is the process of finding the line of the best fits that data points available on the plot, so that we can use it to predict output values for input that are not represents the data set we have, with the beliefs for those output would fall on the lines. Next, let's proceed linear list regressions. X explanatory variables in the functions is multiplied by unknown parameters. These are the most unknown parameters which no corresponding explanatory variables, and all of the individual terms are summed to produce the final function's values. It is different between linear regressions and finding at least square solutions. Linear regressions assumes a linear relationship between the independent and the dependent variables. It doesn't tell you how to model it fitted. Last squared, it simplify one of this possibility. Next, let's talk about QR factorizations. QR factorizations is a linear algebraic operations that factors a matrix into an orthogonal components, which is basic of the row space of matrix and a rectangular components. A QR decompositions of a real square root matrix A is decompositions of A, as A is equals to the QR, where Q is the orthogonal matrix and the R is the upper triangular matrix. Inline regressions. In the static nonlinear regressions, the form of regressions analysis in which observational data are modeled by the functions which is non-linear combinations of model parameters and depends on one or more dependence variables. The transformable linear models involves a single predictors variable in which transforming y and x or both results in the linear relationship between the transformed variables. Polynomials models involving one or more predictors variable, which includes higher order terms as b1, b11, b1 2x, and x2. Next, we have the polynomials interpolations. Polynomial interpolation is a method of testing values between a known data. The values of the largest exponent is called the degree of the polynomials. If the set of data contains n known points, there exist exactly one polynomials on the degree n is equals to 1 or smaller than passes through all of those points. How do you find the interpolations of a polynomials? One of the divided difference have been computed. We can compute the interpolations polynomials f(x) having the degree of less than or equal to n using the following formula. The Lagrange interpolations or the Lagrange interpolations formula is a way to find polynomials which takes on the certain values of arbitrary points. The Lagrange interpolations formula, since Lagrange interpolations is also an nth degree of polynomials extended to f(x) in the nth degree polynomials passing through n plus 1 points in the unique, hence that Lagrange and Newton divided different approximations are one and the same. So next we have the extrapolations. Extrapolations is the estimations of values based on the extending as known as the sequence of values that facts between the area that uncertainly known is in general sense to extrapolate for something that explicit stated by existing. Extrapolates are defined as the speculate, estimated, or arrive at the conclusions based on the unknown facts or observations. For the example of extrapolate is deciding it will take 20 minutes to get home because it took 20 minutes to get there. Now let's talk the spalines and piecewise. In mathematical field of numerical analysis, spalines is the interpolations is a form of interpolations where the interpolant is especially type of spacewise polynomial called the spalines. What is the piecewise interpolations? And the interpolates given the functions at its subinterval as with the polynomials of low degree, which is the piecewise polynomials interpolations ideas. The xi are called the breakpoints. Linear spalines, spalines or linear spalines is the interpolations, the form of interpolations where the interpolant is special type of piecewise numerical is called the splines. Spline interference can produce the value of all points used to curve fittings, but still have smoothly changing gradients. Next, with the quadratic splines, we use quadratic B-splines to reconstruct an approximate functions by using the integral values of successively in sub intervals rather than the usual functions values of knots. It's called the integral quadratic splines interpolations. Next, we have the cubic splines. Cubic splines is the interpolation of mathematical method commonly used to instruct of new points within the boundaries of sets known points. There are the points that are function values of interpolations functions, which itself consists of multiple cubic piecewise polynomials. And now we have the multidimensional interpolations. In numerical analysis, multi-diverse interpolations is interpolations of functions in more than one variable with the variables as spatials and coordinates. So that's the end of our reports from the part 1 until part 5. So if you have any concerns, just subscribe with our YouTube channels, pop up in your screen, and don't forget to subscribe and for the new updates on how we can add more learnings on mathematical and engineering way of process. Again, this is Rhogen Esteban, Bachelor of Science in Mechanical Engineering of Green Valley College.